Hello, this is Mr. Stansbury. I'm going to take you through the 5B notes on presenting and interpreting data. Okay. At the end of this, you should be able to organize and display both categorical and discrete data. And then also you should be able to describe the distribution of data and find outliers. All right. So let's jump into what this all means. So first thing we want to take a look at is organizing categorical data. Okay, so a good way to organize categorical data is with a tally and frequency table. Okay, and that is this here, and this is actually from your book on page 112. Okay, so all right, so this is the example that they give of our frequency tally and frequency table. So these were supposedly 4 types of gas. I don't know what this is, like leaded replacement, LPG, I have no idea, diesel, and then unleaded. So they someone took a survey of all the people that came through, or at least up to 50 people it looks like, and what they did first is they just made a tally mark next to each one. So unleaded, unleaded, LPG, unleaded, diesel, lead republic, or whatever, lead replacement. So, and then excuse me, at the very end they went through and tallied these all, they counted up all these tallies here, and they came up with the frequency. So that means that there's 28 tally marks here, 12 tally marks here, 8 tally marks, and 2 tally marks. Okay, so this is called a tally and frequency table. All right, now another way, well, a way of actually displaying it in some kind of chart or graph, the categorical data, are these 4 things here. Okay, and again, all these graphs here are made from this tally and frequency table up here. So here's a vertical column graph, so, or usually known as a column graph. Here's a horizontal bar chart, pie chart, where each one is broken down into percents. Of course, the percent's not actually listed there, but it's made by percent. And then a segment bar chart, which is also made by percent. I guess you could actually make it just by a total number too, but these are 4 different ways of displaying categorical data. This vertical column graph, or again the column graph, is probably the most widely used, and then sometimes you'll see a pie chart, and once in a while segment bar chart, but you don't see horizontal bar chart very often. Alright, so let's take a look at how to organize discrete numerical data. So ways of organizing discrete numerical data is, again, you can still use a frequency table, right? The tally and frequency table like we just saw. You can also use a dot plot, right? So these two are related, so there's 2 3s, so there would be 2 dots, 1 for each 3. So the frequency would be the number of dots here. So there's the number 4 was tallied up 9 times, so there should be 9 dots here, 13 dots here, 5 dots there, 1 dot there. Okay. Another example, it would be a stem plot, they call it, or a stem and leaf plot. And this one here, this is the first digit and this is the second digit. So for example, all the data for this one here would be, the first one would be 9, and then the next one would be 17, because that's 1, 7, and then the next one would be 11, 28, 23, 26, 26, 27, 26, 24, so forth and so on. So again, this is the tens place, and these all are the ones place here. Okay, so that's another way to look at it. Now, when you're deciding how to organize your discrete numerical data, you need to kind of pick which one would be the best. Now, if you look at this one here, the numbers 3, 4, 5, 6, and 7 show up. This one would not be a really good one to show as a stem and leaf plot, because if you show this as in a stem and leaf, the stem and the leaf, they're all single-digit numbers. So your stem is going to be 0 on all of these. And then like if we were going to just list these all in order like this, it would be 0, 3, 3, and then we'd have 9 4s, so forth and so on, all the way down to the last one, which would be there was 1 7. So they would all be listed out in a big long line like that. So that would not be a very good way to display this data. Okay. Same example. This data here would not be a really good one to do probably as a frequency table, because again you go all the way from 9 up to 51, so that would be a lot of numbers to list in there. You could make it as a range on a frequency table, which would be fine. You know, like say the I don't know, like you could do the from 0 to 9, from 10 to 19, 20 to 29, so forth and so on. But this over here works good for this data. This stem and leaf works good for this type of data here, where you don't have a whole lot of repeating numbers. This is good if you have a whole bunch of repeating numbers. Like again, there's 13 5s. There's only a few repeats in here, like there's 2 26s, 2 35s, and that looks like about it. So anyway, that's how you would organize that data. So let's take a look at a few more things, and then we'll take a look at an example. So describing the distribution of the data set. So here's our data set here. Many data sets show symmetry or partial symmetry about the mode, and when you get, and that's an example here, so there's the mode, that's the one that happens the most often, and it's got a nice little even shape to it. It's symmetrical, right? Because if you take this and cut this in half here and fold it on top of itself, then you would end up getting the same exact graph. That's the symmetry. Okay, we call this a symmetrical distribution. Okay. All right. Now, sometimes the data can be skewed as well. So again, here's a nice symmetrical distribution. So you fold it one side to the other. Sometimes the data is going to be skewed to the right, and when it's like there's more data on the right side, it's called a negative side. The negative side is stretched. So in other words, like you kind of picture holding onto this here and you pull it this way. So this negative side here got stretched. So this is a negatively skewed distribution. Okay. And then the other way is if you take that top piece and pull it to the left there, the positive side gets stretched. So that's called a positively skewed distribution. All right. Okay. Last thing, we're going to take a look